When people imagine snowflakes, they imagine perfection. 6 matching arms, balanced symmetry, tiny frozen geometry falling quietly from the sky. And sometimes that's exactly what we see. But the longer you look at real snow crystals, the more you realize something unexpected. Perfect true snowflakes are not the rule. They are actually the exception. Because every once in a while, a crystal shows up that feels almost wrong. A snowflake shaped like a triangle, one arm that grows wildly larger than the others. 2 crystals fused together as if they met midair and decided to continue the journey as one. And when scientists see these, they don't dismiss them. They lean in closer. Because strange snowflakes often reveal something very important. The atmosphere is far more chaotic than it looks from the ground. We're going to step inside the strange side of snow. The snowflakes that shouldn't exist, and the hidden physics that allow them to form anyway. Before we talk about the strange ones, we have to understand the rules. Ice forms in a hexagonal structure, 6 sides. This happens because of the way water molecules connect when they freeze. Chemistry. And under calm, stable conditions, that structure leads to balance. Each arm of a snowflake grows in nearly identical surroundings. Same temperature, same humidity, same exposure to vapor. And that's why symmetry happens. The crystal isn't trying to be beautiful, it's just following physics. But clouds are almost never calm. Imagine a snowflake beginning to grow inside a cloud. Everything is balanced at first. Then the air starts to shift. Maybe turbulence rotates the crystal just slightly. Maybe it moves into a pocket of air with more moisture. One branch receives a little more vapor than the others. At first, the difference is tiny, but growth amplifies differences. The longer arm sticks out farther, which allows it to collect even more vapor. And slowly, symmetry begins to drift. This is one of the most important ideas in snow crystal science. Tiny differences become big ones. Not instantly, gradually, quietly. Which honestly sounds a lot like life sometimes. One of the strangest examples, triangular snowflake. At first glance, they look impossible. Ice wants 6-sided symmetry. So why would a crystal grow into 3 dominant sides? Scientists have studied this for decades. The current idea is that slight aerodynamic differences might encourage certain faces to grow faster. Another theory suggests that instability during early growth gets amplified as the crystal falls. What's important is this: the crystal is still hexagonal at the molecular level. It hasn't broken the rules. It's revealing how sensitive growth really is. The atmosphere nudges and the crystal responds. And suddenly, something that looks impossible appears, not because nature ignored the rules, but because it followed them in a complicated environment. Some snowflakes don't grow strangely. They change identity entirely. A crystal may begin as a simple column. Then, as it moves into a warmer layer of cloud, plates begin to form at the ends. The result looks something designed. These are called cap columns, and definitely some of my favorites to see. They tell us something powerful. Snowflakes are not formed in one place. They travel. They move through layers of atmosphere, each one leaving a mark on the final structure. A snowflake isn't a snapshot, it's a timeline. Basically, some snowflakes go through more phases than people do. The clouds are not always peaceful places. Crystals fall at different speeds. Turbulence moves them unpredictably. Sometimes 2 crystals collide. Most collisions destroy symmetry, but occasionally the collision is gentle enough that the 2 crystals stick together. And then something amazing happens. They keep growing together. Scientists call this twinning. 2 separate beginnings sharing one final form. When you see one, it feels almost surreal. Here's what makes these rare crystals so valuable to scientists. They show where sample models break down, because laboratory growth often produces neat, predictable structures. Real storms don't. Real storms include turbulence, temperature shifts, humidity changes, collisions, rotation, all the messy things that make weather. Rare snowflakes are not anomalies. They are evidence, proof that the atmosphere is dynamic and alive with mood. Looking at a strange snowflake, you are truly seeing motion frozen in form. We tend to think of snow as peaceful, quiet, still, but the truth is very much the opposite. Every snowflake has survived chaos, air currents, collisions, temperature changes, and somehow it reaches the ground carrying the story of that journey. Snow crystals feel so captivating because they reveal that even the smallest things are shaped by forces we cannot see. And sometimes the most interesting beauty happens when symmetry breaks. The next time snow falls, look a little closer. Somewhere in that storm might be a crystal that shouldn't exist. And that tiny, impossible shape might be the atmosphere telling you its story. New snowflakes are in the gallery. I'll see you next Sunday.